at equatorial region, so the attraction will be less, so expansion of the air will be more. So this is the basic concept behind the tropospheric layer. Okay. So now if I will say, now you can say here the temperature is more. The temperature is more here. Okay. So let us remove these things. Okay. So I have already told here what will happen. As we move upward, the temperature will decrease. So here the temperature is this is 50 degrees centigrade. This is 30 degrees centigrade, 25 degrees centigrade. So actually this is the. So if I say the temperature, then the temperature, normal temperature 20, whereas this is 30 degrees centigrade. Now the temperature will decrease from 30 to 40 degrees centigrade towards the minus 60 degrees centigrade. As we move upward, then the temperature will decrease. Okay. So now, what will happen? You can say here the temperature of the layer which is present below is more as compared to the temperature of the layer which is present above. Yes or no? Let us this temperature is 20 degrees centigrade. Here the temperature is like this is minus 40 degrees centigrade. So what will happen? So here as the temperature, you can say here as the temperature, this is a warm air. This is the warm air, but this is the cold air. As we know, if cold air is present above, it is present above, and this is cold air, and if the warm air is present below, then what will happen? Now the warm air will move upward and the cold air will move down. Yes or no? The warm air will move upward, whereas the cold air will move downward. This is the basic concept. As we know, if the temperature of the air will increase, then what will happen? The density will decrease. So if the density of the warm air is decreasing, then it will slowly move upward. And whatever the cold air is present above, the density is more, so it will move downward. So there will be this is warm air move upward, and the cold air move downward. So there will be a convection. Here I can say convection current is there, or we can say vertical air movement is there. Vertical air movement is there. Yes or no? Or I can say there is air turbulence. Air turbulence is there. Yes or no? So you have to remember these things as the temperature is decreasing. So warm air is present below and cold air is present above. So there is a chance of convection. There is a chance of convection of current will be there. So I can say turbulence is there. Vertical movement of the air will be there. Vertical movement of the air will be there. So as the vertical movement of the air will be there, so here देखिए अभी जो एरोप्लेन हवा में चल रहा है, so the aeroplane, if the aeroplane is flying above the sky, then what will happen? If the air turbulence will be there, then what will happen? Now the aeroplane can't be stable. Yes or no? If the vertical movement of the air will be there, that means air turbulence is there. So there is no stability of the aeroplane. So it will just fluctuate. The aeroplane is not stable. So now we will say, now I can say the aeroplane cannot fly. I can say here the aeroplane be stable. Okay. Second thing, as most of the weather parameters are happen there, because most of the 90% water vapor is there. So what are the clouds are there also, cloud formation is there. So this is known as the troposphere, is also known as weather sphere. Troposphere is also known as weather sphere, because all of the weather phenomena are occurring in this troposphere zone. Okay, and I can say this is the densest, as I can say 85% of the atmospheric mass is there. So this is the densest zone of the climate. Okay, so this is the basic concept of the troposphere. Now we will move to the stratosphere. Now let us move to the stratosphere region. So here you can say stratosphere. Now from 18 to 50 kilometer. This is 50. So from 18 to 50 kilometer, stratosphere will be there. Okay. So this is the stratosphere. This is the troposphere. Then this is the stratosphere. So if I will see the stratosphere, then it is up to, this is up to 50 kilometer. Okay, that means the troposphere height is 8 to 80 kilometer. The 8 kilometer is at height of the troposphere is 8 kilometer at pole, whereas the 18 kilometer in case of equator. I have already explained what is the region behind it. Okay, so now if I will see the stratosphere, so now what will happen? In the stratosphere, ozone layer is there. Okay, as we know, the stratosphere contains ozone layer. Here I can say ozone layer is there. Ozone layer is there. And this ozone layer starts from 15 kilometer to somewhat 30 kilometer or 40 kilometer. That means I can say ozone layer is of two types. One is tropospheric ozone and another is stratospheric ozone. So ozone is two types. One is troposphere, because 15 to 18 kilometers is there for troposphere. So there is the tropospheric ozone and another is stratospheric ozone. So now what will happen? If I will say the reaction, now what will happen? Oxygen molecule is there. So now photon is there. If photon is there, what we will say? H nu. So which is the wavelength 240 nanometer. It may be less than or equal. So what will happen in this case? Now the oxygen will dissociate, or it will deplete to two atoms. O2 will give two atoms. Again, this one atom will react with another oxygen atom to give ozone. So now ozone formation will be there if the wavelength of the light is 240 nanometers. So what will happen? Yes, I have seen here the oxygen. Here what will happen? The oxygen absorb the solar light, the sunlight, or we can say it will absorb the heat in the form of UV light. And you know the UV light is harmful, which is absorbed by the ozone layer. Okay, and this is the current topic for which Montreal Protocol is there. Ozone hole. We will say ozone hole in Antarctica region. So ozone hole is there. That is a Montreal Protocol will be there for climatic change. So what will happen? This is a thing where ozone will absorb the UV light. So that means the ozone will absorb the heat energy. So if the absorption of heat energy will be there, then what will happen? Here the temperature will increase. As there will be absorption of the heat, then there will be temperature. Here the temperature will increase. Here the temperature will increase. Okay. Why? Because ozone is absorbing the sunlight, so the temperature is increased. So now you can say here the temperature, which is temperature of the air present below, it is less. Yes or no? Here the temperature of the air present above is more. That means it is warm air which is present above condition, but it is a cold air. I have told if the warm air, if the warm air is present below and cold air is present above, then warm air will move upward, cold air will move downward. So there will be a vertical movement of the air. Vertical movement will be there. But remember, if cold air is present below and warm air is present above, then there will be no vertical movement. No vertical movement. Okay? So here warm air is present below and cold air is present above. So there is a vertical movement. So turbulence is there. So aeroplane cannot move. But here cold air is present below and warm air is present above. So there is, I can say, here no convection. Here I can say no convection, or I can say no vertical movement. No vertical movement, or I can say no turbulence. That means here aeroplane can move. Here so here aeroplane can move in the stratosphere zone. Always remember, now the ozone layer is present in stratosphere zone. So most of the ozone layer is present in lower stratospheric zone. Lower stratospheric zone, most of the ozone layer is present. Okay. So now here you can see there is a zone between the stratosphere and the troposphere. This is known as the tropopause. This is known as the tropopause. This is known as tropopause. Tropopause is a transitional zone. Is the transitional zone between this tropopause is the transitional zone between troposphere and stratosphere. So here you can see the most important point is that there is no change in temperature. There is no change in temperature within the tropopause or within the transition zone. There is no change in temperature within the tropopause. Okay. Then after that the temperature will increase. Okay. This is the basic important thing. So now let us move to the next zone. Troposphere, the stratosphere. Then there will be mesosphere will be there. Then there will be mesosphere. So here if I will go to the mesosphere, so here I will move to the mesosphere. Now mesosphere will move somewhat, it is 80 to 85 kilometers. Now it will move somewhat 80 to 85 kilometers. So now this will be the mesosphere. So there is nothing much more important. This is mesosphere, and you can say in mesosphere, whatever the meteors are there, you know meteor, whatever the meteors will come from the upper layer, it will burn up here. It will burn up here. It will burn up here. So whatever the meteors are there, they will be destroyed within this mesosphere. Okay. And the distance and the transitional zone between the mesosphere and the stratosphere, this is known as the stratopause. This is known as the stratopause. This is known as stratopause. As we have already known, there is no temperature change within the transitional zone. And now the mesosphere, as we move upward in the mesosphere, as we move towards more altitude, then what will happen? Now the temperature will decrease. Within this zone, the temperature will decrease. Within this zone, now the temperature will decrease. This temperature will decrease up to minus 90 degrees centigrade. Okay. So within this lower, this is the 1 or less than 1% of the atmospheric mass is there. In the lower layer of the mesosphere, the atmospheric mass of the air is very less, and this is less than 1% of the atmospheric mass. That means I can say what will happen if this is 85% mass will be there, then approximately I can say 15% air mass will be there. I can say 15% of air mass will be here. So I can say in stratosphere 15% air mass or atmospheric mass will be there. In 85% will be in troposphere zone, and 15% mass will be there in stratosphere zone, and whatever the remaining very trace amount of air will be there at the mesosphere. So in the mesosphere the temperature will decrease up to minus 90 degrees centigrade. Okay. Then there will be major pause. Major pause will be there, and there will be another sphere. Another sphere I have already told. This is the, and I can say this is the thermosphere. If I will say this is the thermosphere. Above the mesosphere, then there will be a thermosphere. And you remember here one thing: the lower layer of the thermosphere, is known as ionosphere. The lower layer of the thermosphere is known as ionosphere. Why it is ionosphere? Because in this ionosphere, most of the positive charge particles are there. Okay. So this is known as the ionosphere. And we can say thermosphere is the outermost layer. It is the outermost layer. But again, if I will say the temperature will increase in the thermosphere. Now this is the transition zone, that means the temperature will remain constant. Then the temperature will increase. Okay. So the temperature will increase in case of thermosphere. In some books, there will be another. Just we can say that this is the lower layer. Lower layer of the thermosphere is known as the ionosphere, and another layer we can say this is the exosphere. This is the we can say this exosphere is the connection between the space and the atmosphere. I can say here I can write exosphere, here atmosphere, and another which is space. So the connection, this is the connection. Connection will be the, if I will say the connection, then here the connection will be the exosphere. So here I can say the exosphere is the connection link between atmosphere and the, we can say, the space. And one most important thing is that if I will say in ionosphere, then we hear the long distance radio communication will be there. In ionosphere, the most important property is the long distance radio communication. Long distance radio communication will be there. That means if a radio if a news is there which is occurred in Australia, then it can be communicated with respect to the India. So long distance communication, radio communication will be happened due to the ionosphere. And remember, the ionosphere contributes the positive charged particles. Okay. So this is the basic important thing I have already told. So whatever the 85% mass, so whatever the 15% atmospheric mass will be there, this is up to 40 kilometers, because I have already told within 40 kilometers 99% of the atmospheric mass will be there. Okay. So this is the basic thing. So here if I will ask some questions, then my question will be, here if I will ask some question which is asked in different examination, so we will discuss in a later part. Okay. So we will make some objective based on this chapter, then we will go for a discussion. Okay, thank you.